Unit 8 Fractions, Booklet 4. Simplified Rational Expressions. 42 over 105. Numbers that you want to check to see if they go into numbers to simplify would be like 2, 3, 5, 7. Just the first few prime numbers. Well, they're not both even, so we can't do 2. Looks like we can do a 3 though, because if you add the digits together, 3 goes into that number. Okay, 42 divided by 3, 14, and then 35. Okay, it looks like we can't divide by any more 3's. And we can't divide by 5 because both numbers don't end in a 0 or a 5. We can divide by 7 though. So we have 2 over 5. That is our reduced fraction. On the next one we have some variables. Let's recall this law of exponents. A to the m over a to the n equals a to the m minus n. This is a quotient rule. So we'll simplify the 6 and the 4 like before. We divide each of them by 2, they're even numbers. And then we're going to subtract the 2 exponents. Two minus 1/2 would be 1.5. We can multiply each of these by 2. And then we have 3n to the 4 over 2 minus 1 over 2. And that's going to give you 3n to the 3 over 2. You could also write it like this. 3n and square root n over 2. Let's look at the next one. So we have a 1/2 as an exponent on the outside. 150 really has an exponent of 1. This could be power of a power. A to the m to the n equals a to the m times n. So I give you 150 to the 1/2 x to the 6 over 2, and then square root of 6 is 6 to 1/2. From here we can rewrite this. Six over 2 reduces to 3, and since these both have 1/2 powers, we can write them inside the same radical. That'll give you x cubed square root of 25. The square root of 25 is just 5, and so we have 5x cubed as our simplified expression. Let's look at this one. We have 10v squared minus 60v all over v squared minus 7v plus 6. So instead of using our law of exponent properties, on this one we're going to factor it. We have factored the numerator by taking out the GCF, and GCF is 10v. So we're left with v minus 6 on the inside. And then we'll factor the denominator. So we will find two numbers that multiply the 6 and they add to negative 7. Two numbers that would work here is negative 6 and negative 1. So our factored form would be v minus 6 and v minus 1. Okay, these cancel. You would have a hole there. And so your simplified expression is 10v over v minus 1. Before moving on to the next page, answer the question in the box. I can simplify rational expressions by, in your own words, describe what we were doing on this page to simplify these expressions. Pause the video. Once you answer the question, move on to the next page. On the next page, we're multiplying and dividing rational expressions. For multiplying, you would multiply straight across. Before you do that though, see if you can simplify as much as you can. There's a r plus 3 up here. There's a r plus 3 down here. They cancel. The r minus 2's cancel. And then let's see if we can rewrite this to make it look more like r minus 6. So if we factor out a negative, we could have r minus 6. We change the signs of each and put the negative on the outside. Now those r minus 6's also cancel out. So your simplified expression is negative 7r. Now with this one, it's division. With divided fractions, you would keep the first fraction, change the operation to multiplication, and then flip the second fraction. So we'll do that first. V squared minus 13v plus 42 all over 2v minus 14 times, flip the second fraction, 2 over v squared minus 4v minus 60. Okay, next you want factor. Okay, let's factor this first part. We will find two numbers that multiply to 42 and they add to negative 13. That would be negative 7 and negative 6. So our factored form would be v minus 7 times v minus 6. Let's factor out this part. The greatest common factor of 2v and minus 14 is 2. We're left with v minus 7 on the inside. Two is just 2, so we'll rewrite that. And let's factor out this expression, v squared minus 4v minus 60. So we want to find two numbers that multiply negative 60 and they subtract to negative 4. We would have negative 10 and positive 6. Our factored form would be v minus 10 and v plus 6. From here, let's see what cancels. There's a 2 in the numerator, 2 in the denominator, they're gone. V minus 7s, they go away. V minus 6 and V plus 6 are not the same, so we're going to leave those alone. And then you just rewrite it again. V minus 6 all over V minus 10 times V plus 6. And that would be your simplified expression. So your steps, we want to keep, change, flip, factor, and then cancel out like factors. At the bottom of this page, answer the question. I can multiply, divide rational expressions by. Describe in your own words, how do you solve similar problems like this? What are the steps? When you're done with answering the question, move on to the last page. This page is all about adding and subtracting rationals. If we look at the first example, they have like denominators. So that means we could just add them straight across. It would look like this. B plus 4 plus B plus 5 all over 7B plus 3. Combine like terms and see if anything simplifies further. 2b plus 9 over 7b plus 3. And that would be it because nothing else would cancel. But look at the next one. Those denominators are not the same. So we're going to multiply the first fraction by k plus 2 over k plus 2. And then the second fraction by 5k over 5k. So we'd have 2k plus 2 over k plus 2 times k 5k minus 5k k minus 3. And then k plus 2 times 5k. We could change this side to a plus and change this to a minus. Distribute the negative 5k into each of those. 2k plus 4 minus 5k squared plus 15k all over k plus 2 times 5k. From here, combine like terms. We get negative 5k squared plus 17k plus 4 all over k plus 2 times 5k. From here, you want to see if it factors anymore. It doesn't in this case, so we're done. Let's look at one more. We have 3 over 2n minus 3n over 2n plus 6. Well, 2n plus 6 is the same thing as 2 times n plus 3. Let's find the least common denominator of 2n and 2n plus 6. So you could divide out 2 out of both of them. You're left with n and n plus 3. Your least common denominator would be the product of this, this, and this. So this is the GCF, and then all together, that's the least common denominator. So if we do that, we have 2 times n plus 3. That's our least common denominator. Okay, so from there we want to figure out what to multiply each fraction by to get this. So the first fraction we're going to multiply by n plus 3 over n plus 3. And then the second fraction we're going to multiply by n. Because there we have the 2, and there we have the n plus 3, they just need another n. So when we multiply those, we get 3 parentheses n plus 3 minus 3n times n, all over 2n times n plus 3. So then we have 3n plus 9 minus 3n squared. We have negative 3n squared plus 3n plus 9 all over 2n n plus 3. On this one we could factor out negative 3 and get n squared minus n minus 3 all over 2n n plus 3. It doesn't look like we can factor it any further, so that would be our answer here. At the bottom of the page, answer the question in the box. I could add, subtract rational expressions by. Describe the process from the examples above in the box in your own words.